Helpful to know is the trends for reactivity, the way that one substance chemically interacts with other substances. Highly reactive substances often react explosively, but we also see evidence of reactivity in the production of gas bubbles, a change in color, or the formation of a precipitate. The periodic table can help us explain why some elements are reactive, some are really reactive, and others are just not. Let's begin our story by looking at why sodium is reactive but neon isn't. Neon atoms have 10 electrons, while sodium atoms have 11. This doesn't seem like much of a difference, but their electron configuration shows us why it matters. Neon has a full outer shell with 8 electrons. There's a rule of thumb that atoms prefer to have a full valence shell. Since neon has this, it doesn't need to react with other atoms. It's satisfied all by itself. Neon and the other elements in group 18 of the periodic table are known as the noble gases. They all have a full outer shell of 8 valence electrons, or 2 in the case of helium, and this makes them unreactive. In contrast to neon, sodium has 1 electron sitting in a valence shell all by itself. According to the rule of thumb, it wants to have a full valence shell, so this lonely valence electron won't do. A sodium atom can get rid of this electron by a chemical reaction. Atoms react and form bonds by either sharing or transferring valence electrons. For example, sodium can transfer its electron to a chlorine atom, and they can react to form a happy couple, table salt. Sodium and the other elements in group 1 of the periodic table are known as the alkali metals. They all have 1 valence electron that can be transferred in a reaction. This makes them all highly reactive with substances like water, oxygen, and acids. But we also observe that reactivity increases as we move down group 1. For example, cesium is much more reactive than sodium. Why? Well, it has to do with the size of the atoms. The distance from the center of the nucleus to the outer shell is called the atomic radius. Atomic radius increases down each group in the periodic table as each electron shell is filled. For example, lithium has 2 shells containing electrons, while sodium has 3. Sodium's valence shell is further from the nucleus, so it has a larger atomic radius. This explains why sodium is more reactive than lithium.
Come at me, bro.
Electrons orbit the nucleus because they're attracted to its positive charge, and this attraction gets weaker with distance. So as atomic radius increases for the alkali metals, valence electrons are more easily lost to other atoms in a reaction. The really big alkali metal atoms, like rubidium and cesium, lose their valence electrons most easily. The largest atom, cesium, is the most reactive of the whole group.
That's right.
The same trends of atomic size and reactivity also apply to group 2, the alkaline earth metals, although they are slightly less reactive than the group 1 elements. So the periodic table isn't just any table, it stores a wealth of information about elements and how they interact. We just have to learn how to read it.